Now, it doesn't have to just be the force that's being transmitted by the plastic platform. It could be a force at a great distance, for example, the force of gravity. Just these small, little, seemingly insignificant pushes building up over multiple cycles can have dramatic energy transfer. That is how planets do it.
Like the metronomes, the two gas giants form a resonance.
We don't know exactly how long that took, but we have some fiducial marks for timing in the solar system formation, and that means that the grand tack had to have occurred relatively quickly, talking hundreds of thousands of years, perhaps, to a million years.
The two planets retreat until they reach their current positions. The sequence of planets as we find them today is based on Jupiter and Saturn's orbits. The planets eventually achieve a sequencing that many students learn through a mnemonic, such as, "My very educated mother just served us 9 pizzas."
Was there a time when the mnemonic was scrambled? Seems very likely the answer is yes, not to mention a lot of additional letters were probably in there as well.
Jupiter's menace of the inner solar system is finally over.
If Saturn had not formed at the right time and the sufficient size, Jupiter would have continued migrating in, throwing out objects, unfortunate objects in the inner solar system, and ending up very close to the sun where it would stay. Yes, the Earth would be gone. Or the Earth would have had a terrifying encounter with Jupiter and would have had its orbit changed dramatically to gosh knows what.
There is mounting evidence that Earth had a terrifying visitor. Not Jupiter, but another world. Theia.
Theia was essentially another proto-Earth, where there were a number of these objects flying around. And Theia took time to grow just like the Earth did. They probably had rather similar histories. And for one reason or another, the orbit of Theia was perturbed such that it collided with the Earth.
Theia was this planetary body that was roughly the size of Mars. And through this collision, a lot of particles were ejected, probably completely destroyed. We don't really know how much of Theia was preserved.
Earth is rocked off its axis. Its surface liquefied. Chunks of Earth's mantle are shoved into space. As a planetary body, Theia ceases to exist. Its remains are absorbed by the Earth and intermingled with the debris field. A new planetary body is formed, the Moon. Further evidence is found in rock samples from the Apollo moon landings.
This is a sample from the Moon, if you can see it. This was collected by the Apollo 15 mission.
Moon rocks contain isotopes identical to those found on Earth. When the Moon arose, it is first covered with a magma ocean.
People imagine the lunar magma ocean to be like this magmatic chamber I am describing, but at the surface and covering a whole planet. I see it as this ocean, like the Pacific, but this has to be like completely magmatic, orange, and like probably like fluxing around and probably moving.
Conditions in the lunar magma are as hellish as we can imagine. But a microscopic treasure forms in the magma: crystal zircons. These are the same gemstones used in jewelry. But the zircons in the Apollo moon rocks yield a different treasure:
So those zircon are very important because we know they crystallize in this lunar magma ocean. We know roughly when they crystallize in the lunar magma ocean. So they are one of these old pieces of the moon that we are looking for, one of these old pieces that we can use to date the origin of the moon.
Zircons not only give the age of the moon, they set a specific date for the collision.
The age of the moon is 4.51 billion years old.
4.51 billion years ago, Theia becomes part of Earth and forms the moon. But the story is not over. Space probes measure the moon slipping 3.8 centimeters further away each year. One day, the moon will break free. When that day comes, there will be no more tides, no more romantic moonlit nights. Could planetary orbits be inherently unstable? Could the chaos of planetary migration return? Haute-Provence Observatory, France. It's here that a discovery from a faraway star gives one of the biggest revelations about our own solar system. The story begins when Swiss astronomers Didier Queloz and Michel Mayor noticed something unusual about a star 50 light-years away in the constellation of Pegasus. Everything about this star is ordinary, a main-sequence midlife yellow dwarf, just like our Sun. But with one strange difference. The star at Pegasus 51 is rocking back and forth. It's a weird anomaly astronomers have never seen before. They check their instruments. Everything is working, including their new spectrograph, a device that splits the starlight from Pegasus into rainbow colors. Hidden inside the colors are patterns of lines. By tracking the day-to-day movement of these lines, astronomers make a startling discovery. Pegasus 51 has a planet. But no one has ever seen a world like this. It's half the mass of Jupiter, yet it's extremely close to its star. 9 times closer than Mercury is to the Sun. The planet at 51 Pegasus must be inside the corona, broiling in temperatures over 1,000,000 degrees Fahrenheit. Soon, another planet is found around another star, and then another, and another. Astronomers have now confirmed over 3,700 exoplanets beyond our solar system. Nearly all of them are Jupiter-class planets, grazing their host star. They're a new, previously unknown type called hot Jupiters. They're so numerous, hot Jupiters challenge theories about the origins of planetary systems.
It's very difficult to make a planet close to the star because there isn't enough mass to build a giant planet very close to the star, and there's gravitational frustrations for trying to build a planet very close to the star.
Astronomy is shaken with a new revelation. Planets do not stay put where they're born. When they're big enough, they migrate. It's a process called planetary migration. And yet, our own solar system has no hot Jupiter. Astronomers realize the Jupiter in our solar system was once on the move as well, but its migration was halted by a resonance with Saturn. Pegasus 51 shows where a planet lands when its migration is not blocked. The strongest evidence for the Grand Tack hypothesis comes not from our solar system, but from exoworlds charted around other stars.
Planetary migration is a universal concept. We see it, evidence of it out there in extrasolar planets, other solar systems. There's no reason why planet migration shouldn't have operated in our own solar system.
the New Horizons probe finds evidence for roving planets within our solar system. While charting ancient craters on Pluto and on the surfaces of its moons, the science team discovered many craters are the same age. This suggests that they were formed by a single event. Even way out here, tiny Pluto was smashed by a wandering planet. The Pluto catastrophe may be related to other planetary migrations in the outer solar system.
It was noticed that the exact orbits of the giant planets, particularly the outer giant planets, the icy planets, Uranus and Neptune, can be explained by their migration outward. There's a point in time about 3.8 billion years ago where Uranus and Neptune trade. And it's because of what some of these mean motion resonance interactions that we were talking about earlier. So this mean motion resonance